So thank you all for coming by today, and thank you for following us with this really nice event, Light Up 2020. The title of this session is SQL Containers in Microsoft Azure. My name is Carlos Robles, so I will be your presenter today. I'm in for this session. Please remember, this is goodwill. We're trying to donate as much as we can to UNICEF in support of the kids and everything is going on with COVID-19. This event is not possible without our sponsors. So please take a time to say thank you, and thank you to C Sharp Corner and the Text Platform, who are the organizers of this event. If you want to send some feedback for the speakers or the event, please scan the QR codes on the screen so you can provide that feedback that I am sure will help the guys that are organizing this event to improve things in the near future. So as I said, my name is Carlos Robles. I am originally from Guatemala, living in the United States for the past 3 years. I have more than 10 years of experience working on the database administration field with multiple platforms. Nowadays, I perform more as a solution architect for on-premise or cloud solutions for my clients. About my community work, I have the honor to be a Microsoft Data Platform MVP and also a friend of Redgate. I have also a great honor to be the Guatemala SQL Server User Group leader. I do this remotely. Obviously, I don't live in Guatemala anymore, but with help of the other co-leaders that are located in Guatemala, we organize meetups and everything else. I have certain experience as author. I write technical articles for Redgate Simple Talk, for SQL Server Central, MS SQL Tips. I represent my blog consulting company called DBA Mastery. You can take a look at my blog. You will find some tips, scripts, best practices, and more. Of course, my GitHub repository, you will be able to find the slides decks and the scripts and everything else that I will be using during this presentation. So please take a look. But the most important thing on this slide is my contact information. We can connect on LinkedIn if you want, and you can ping me on Twitter. My DMs are open, or you can send me an email. So please don't hesitate to ask me a question. And by the way, I would like to address the questions at the end, so I can share as much content as I can. Right, so enough about me. Let's take a look at what I have prepared for you guys today. We're going to have around 50 minutes to talk about SQL Server containers in Microsoft Azure. And my goal with this presentation, excuse me, is to show you why ACI and AKS are the easiest way for you to run SQL containers on the cloud. All right. So the first topic is containers, what and why. And a brief definition of what a container is and why containers are so good to build immutable infrastructure solutions anywhere. Excuse me. Then I will focus on SQL containers from, I will focus on containers from the SQL Server perspective. Finally, I will address the main topics of this conversation, which are Azure Container Registry, Azure Container Instances, and Azure Kubernetes Services. Okay? All right, so this is a brief introduction, something I would like to share with you today. There is a really big opportunity right now, especially for containers in the cloud, because Gartner believes that in the next few years, we're going to see 75% of the companies running mission critical containerized and cloud native workloads in production. That means that there is a lot of chance for you to be at top of this transformation, as well to join Azure in this journey to containerize all the things. Excuse me for a moment, I'm having a little bit trouble with my voice today. I just need a sip of water, so I'm doing okay. All right, so getting back to our presentation. As I said, this is our first topic, containers, what and why. Well, let me tell you this first. Containers are commonly called the standard units of software for a very good reason. It's because a container image can include all binaries, libraries, and dependencies that makes our application functional. Containers are different than VMs, shares the machine's OS kernel or system kernel, driving higher server efficiency, more importantly, reducing the storage footprint and server licensing cost. They are cross-platform. A container created in macOS will run the same in Linux, Windows, or even in serverless services like Azure Container Instances. So next slide is why containers. For those that are new to the world of containers, there is an added value that containers provide over VMs or even function as a service. One of the key things are speed. Containers do not require to load an entire operating system per application, leading to very quick start and stop times, which is really convenient for developers, right? I'm not trying to say that containers are meant to replace virtualization technologies. They are just another tool in your toolbox available whenever you have a software problem. You can leverage this really good technology to solve your problem. Okay. A container includes just the application and user space. That's a lot simpler than a VM in terms of overhead, of course. They are mostly managed by API tools, which makes them really easy to learn and use. Finally, packaging. Having to wonder, do I have all my files, all my dependencies, all everything I need for my application? Worry no more. That's possible with containers. You don't need to worry about it anymore. You just need to specify all those dependencies and all the files you need as part of your Docker file. That makes things really easy for us, right? Okay, so moving to the next topic, SQL containers from the SQL Server perspective. If we stop for a moment, think about the role of databases in today's IT world, we can easily say that databases are pretty important, right? Honestly, I cannot think about an enterprise type application not having a database behind to store important stateful data. Not sure if you remember, but at the beginning of this session, I said that organizations are moving towards containerized applications. So that's very likely that they would like to include SQL Server as part of the new development stack. DevOps demands agile and automated ways to build pipelines for development, stage, or production environments. Excuse me. That's kind of challenging to achieve when we use the monolith development practice. Developers are in the need of simple runtime workplaces where they can have a SQL Server instance integrated as any other component of their application, and also making sure they can manage these instances through code. So there is when containers come into the spotlight, and more importantly about Docker and Kubernetes, because they provide that portability, the agility to run modularized applications on premise or even the public cloud. In this case, today's topic is Microsoft Azure. Okay, so containers in Azure. Well, this session, as I said, is about this topic, of course. So I will provide you a brief introduction of what Microsoft Azure offers in terms of containerized workloads in their platform. And the most important, I will try and do my best to focus or highlight through the demos that durability, network connectivity, and high availability we are always looking for when running any SQL Server workload in the cloud. Microsoft Azure provides us a couple of experiences to interact with containers, obviously. The first one is a graphical user interface. Obviously, is the Azure portal that we all know, love and know. And also we have the command line based clients as the Azure Cloud Shell or the Azure CLI. So I'll be using all of them during the demos to make sure we get a little bit of everything. Okay. Excuse me for a moment. All right, I need another sip of water. My allergies are really bad today. Sorry. So Azure Container Registry, that's our next topic. Okay, so let me go back here. So a registry is a concept that allows us to pull things with a content addressable URL. In the container's case, the content are images. Okay, imagine an infrastructure project for a moment. The first thing you are going to probably build is the storage. So ACR ends being that fundamental component to the overall container ecosystem in Azure. It allows me to manage a private Docker registry as a first-class Azure service where I can still use all the Docker CLI commands we're used to in order to build or push images from my laptop, or using being part of the continuous integration platform as Azure DevOps, Jenkins, or even scripts if you want. It provides you a replication, which I think is a really cool feature for a container registry, because it takes a couple of clicks to get it enabled. And actually, once you have this feature enabled, is really interesting because this registry is going to pull an image from your closest replicated registry in my region, so it adjusts to your needs. And it's really important because from the business continuity standpoint, for a cloud native application, it enables me to recover my entire image repository collection really quick in case of disaster. So that's really important. All right, so let's have our first demo with ACR. Let me just switch things around. Okay. So here's a summary of all the things I will be performing during this demo. Obviously, I don't have the time to go in details in each one of them, but at least this is a general idea what I'm going to do. The container registry is already created. I skip this part because it takes a lot of time. Sometimes, like, not a lot of time. It takes from 1 minute to 2. So I want to save some time. I'll show you some properties about my ACR. We are going to build a custom image of MS SQL tools. I will show you that later in detail. Well, I'm going to grab this image and I'm going to push it into ACR. I'm going to check my repository using VS Code Docker extension. And then finally, I'm going to do the same, but this time using Azure Cloud Shell, which is going to be really interesting, trust me. All right, so I will start with this. These are some variables I need. I will log into my ACR from my Docker just to make sure. All right, so as I said, this is already created. You can go ahead and take a look. All the scripts has a variable, so you can change the way you want. You can play around. It will be just a matter to change the variables for you to reproduce all the demos. All right, so let's take a look at the details about this ACR. Of course, I can list every single ACR on my resource group. In this case, my resource group is Light Up 2020. The location of my ACR is West US. The name is DVA Mastery. I'm using the standard SKU. You can use different, and of course, there will be different price, and of course, there will be more features. So in this case, I just need something really simple to get this going. Here is my login server name and the date I created this repository. All right, so I have my Docker registry ready, so I can start pushing images into it. The first thing I'm going to do is going to show you this Docker file. All right. I know this could be overwhelming at the very beginning or kind of scary, but I will go through everything here and I'll explain you what's going on. So I'm using reusing an existing image, in this case Alpine 311, that to be the base of my custom container. Then I am putting some labels here for informational purposes, a couple of arguments and environment variables. And then here's the most important part. I am adding all my files, libraries, keys, and everything else I need to install SQL command on this image. This is pretty much what I'm doing. I am just grabbing the SQL, SQL command binaries from Microsoft and installing them into this image. Why? Because I just need a SQL command container to be there sitting if I want to quickly spawn a SQL command connectivity to a different server in the cloud or whatever. There is many purposes. This is just for example purposes, but at the end of the day, is going to create a SQL command and it's going to be really quick. Okay, so let's build the image first. And that was probably really fast because I did it before. Well, I was checking my demos. So at this point is done. my image was created. Cool. Let's list the image for a moment. And as you can see, I have my MS SQL Tools Alpine image, the one I created. As I said, I did it before. I can even delete this and do it again, but it's pointless. I will do a fresh image on Azure. So let's keep with this example for a moment. All right, I will start tagging my image because what's going on? Oh, this is already done, so I think I won't be able to do it anymore. Yeah, as it said, it's done. Let me do something really quick here. We can. I think it's not done. Yeah, I was doing it wrong. So there you go. I had my 1.1 tag that I created yesterday. I just simply added another tag to my existing image. It's not a big deal, but what I want to show you now is pushing this image into Azure. It's really easy, and it doesn't change. If you are familiar with Docker, it's pretty much the same. You can see it's done. All right, if I don't want to go to a portal and check the status and make sure this image was pushed successfully, I can use the Docker extension of VS Code. Let me refresh things here for a moment. And here's my repository, DB mastery. And no, sorry, this is my ACR and this is my repository. So I can see my image was created, it says 2 days ago. Obviously, that was the one I was working on. So it's done. But let me show you something really cool and interesting. Let's go to the Azure portal for a moment. All right. It's connecting. Come on. Come on, Azure. All right, so I'm in. So I just need to run a couple of commands here to make sure I am on the right subscription. And now I will navigate to my, wow, what happened? Hey, somebody is controlling my screen. Well, okay, I'm back. All right, thank you. So I will navigate to one folder that I already created. Let me show you what do I have on this folder. I have a Docker file. I can explore this Docker file. Oh, excuse me. If you want, let's take a look. Docker file. And this is pretty much the same I had before, but in this case, I am adding a different metadata because this is going to be the 2.1. I have the 1.0 and 2.0, so I'm going to create 2.1 now, and I'm going to do it in Azure. Oh, once again, guys, could you please stop clicking? Thank you. Right, so I'm going to run this command, and this is exactly what I did for my computer, but in this case, I don't have Docker installed. Obviously, Docker is not installed on Azure Cloud Shell. So it's going to grab this Docker file and it's going to create these MS SQL Tools Alpine 2.1. And that's it, pretty much the same. So this is really cool because if you don't have a machine with Docker installed, you don't need to. You can use or leverage the Azure Cloud Shell to build your images or anything else. So it's done. Let's take a look at my repository for a moment. It's here. Here's my ACR. There is task. There is many things you can do with ACR. I didn't go in detail. I just wanted to show you a really quick sample of how to build a SQL image, and it's here. You can see my 2.0, my 1.0, and my 2.1, and you can even deploy a container from here. I think you just need to click here. Yep, it's not possible because this is not a web container or image. But if you're building a web image, Azure is going to detect it, and you can even run an instance for here. It's really cool. All right, so it's done. My image is there. I can grab my image, I integrate my image with anything else, so I can start working on. Okay. So a quick recap. I was able to build, tag, and push an image to ACR. I use a VS Code extension to check the status of my image repository from my computer. If you don't have Docker, that's not a problem. You can use Azure Cloud Shell to build, tag, and push images into ACR. Okay. Now let's move to a more interesting point: Azure Container Instances. This service enables you to run containers without ever touching a server. If you run containers today, you probably set up your own virtual machine to install Docker, or maybe you're looking to do it in your own laptop. However, if you're running Windows Home, for example, you won't be able to run Docker desktop there. There is alternatives now like WSL2, which is really cool. But anyway, you always have to deal with the infrastructure or the components. With ACI, you can say, okay, I have my Docker image and I just want to deploy it somewhere. I don't want to know about anything about VMs, or I just want Azure to take care of everything on my behalf. And that's it. I just want to run my container. So that's pretty much ACI. And Microsoft's goal is for you to look at container as a new compute primitive, exactly the same way you see VMs today. The same way you interact with them through RBAC or the Azure portal or the Azure CLI. So Microsoft is making sure to provide you the same user experience with this service. On top of that, Azure will let you define your own configuration instead of going to the VM configuration SKU set. You can define how much CPU or memory you need. For example, if you want to have a container that needs to use 1 gigabyte of memory or CPU, you can do it. So it's very flexible, and that's because of micro billing. Azure will bill you by the second for each one of those resources you pick until the container is deleted. So that's really important, guys, that you can be really flexible. You are not tied to a VM SKU. I'm not saying that that's bad, but that's you have choice, and that I appreciate that a lot from this service. And the last component that we have is that we have a secure hypervisor isolation for each of your containers. It's the same security model that is used today for VMs. Okay, so why ACI? The first characteristic is invisible infrastructure. I know this has a larger meaning, but the first thing you need to understand is that actually there are no servers. The containers are running on the cloud, of course, but the server infrastructure is invisible for us. But let me clarify, it doesn't simply run on Vapor or paper. There is a server somewhere in Azure's infrastructure, but the cloud abstraction has chosen to hide it from you. Okay? We simply don't care about any overhead created by these new container. We just want our SQL Server to be there and running. Okay, microbilling means that higher CPU. It means that we can get higher CPU utilization than VMs. Imagine this scenario when you have your new development team and they need to develop a new feature that was requested by your client, and it will take them a few days to complete that new feature, and they need a SQL Server instance to be up for just a couple hours during the day. And so you don't need a dedicated VM for that. You can just deploy a container with exactly what you need, and you can get 100% utilization, 100% CPU memory utilization, and you can just take it down whenever you want. Those are the great advantages of immutable infrastructure, of course, which leads me to the next characteristic, which is modularity. Being able to scale out specific areas that might become a bottleneck in the future is just beautiful. You don't need to scale up the entire VM. You can just scale up one of your containers and that's it. Okay, so let's have a demo about ACI. All right, let me go back to my dashboard here. And now I'm going to get back here. So we are getting into SQL Server containers now. This is going to be a second demo. All right. So I will give you an example of how to create a SQL Server container in ACI, how to check the logs, properties, how to connect using Azure Data Studio. In my case, because I'm using macOS, I can't run SSMS, but it's pretty much the same. You can do it. You have the connection string, you can do it. I will show you the dashboard from Azure Data Studio just to make sure it's the same SQL Server we are used to. And then I will perform a basic container lifecycle management, starting the container, stopping the container, and finally deleting the container. I will try to do it using Azure CLI and also the portal. Okay, so let me focus on my folder. That's okay. Here's an example how to create a SQL Server container in ACI. It's pretty much standard as any other Azure resource. So you have to provide a resource group, a name. Of course, we're talking about containers, so we have to provide an image name. Our environment variables, in case of SQL Server, we have to accept the end user license agreement, provide a password for RSA. We can define a DNS label, and that's in case you want to have a DNS and connect from the public internet. That's up to you. You can use VNets and lots of stuff to protect your environment. I just choose to do it this way because it's simpler for me. Then here's the most important part. Remember I said that with containers, we can define how much CPU memory we want. So in this case, I define it and I'm going to use 4 CPUs and 4 gigabytes of memory. Of course, you need to read the documentation, make sure you are in compliance of the system requirement for SQL Server, I guess, is 2 gigabytes of memory and 2 CPUs at least. And finally, my port. Of course, 1433, sorry, it's going to be the default in this case. I am not going to execute this. This is going to take a minute, but here's the output. Let me close this down. Here's the output you're going to receive is a JSON output that's going to be returned. Not a big deal. It's just metadata. But we can take a look at the logs of my container from here. For example, if I run this command, I should be able to see what's going on. I have a couple of things connecting to my container, so that's why it says SA password is failing. Nothing to worry about. It means it's up and running. I can even list all my containers on my resource group. I have a few here. There you go. Looks better. So I have dev01, dev02, and I have an AG. I will show you that later. So this is pretty much the standard stuff that you can figure out here with these scripts if you want. I would consider this the most important part. You want to connect, right? So you want to know what is your fully qualified domain name, your IP address. So in my case, this is my fully qualified domain name. Why this is important? And it is because it's simple. It's because this is the name or DNS name you're going to use to connect from SSMS, Azure SQL, Azure Data Studio, or your tool of choice. Okay, so let's do it. Let's connect from ACI. Let's connect from Azure Data Studio. I'm mixing up terms. Of course, I have my connections already created here, but I can edit my connection. You can see I'm putting the DNS here, my SA password, my my essay as a username and my password, and that's it. But I'm already connected. So let's explore this container for a moment. Let's go to manage. There you go. So I can see all databases there. You can explore everything else, anything else here. But let's run a query. Let's run a query. Let me go back here for a second. I think we'll have more examples about that. Yep. This was just an example to connect to an ACI. And as I said, you can use your tool of choice, but it just takes to get the DNS name and that you are done. You can connect. Okay, so let me go back here for a moment because we'll have more time to play around with the SQL Server container. Okay, so it's up and running. Let's imagine you want to do some basic lifecycle management because you don't need this container to be up anymore. So we are going to take it down. But before taking down the container, I want to give you a little tour of what Azure provides us here from the portal experience. I love this because you have access to the CPU, memory, network, inbound and outbound information just out of the box. This is really cool. You can monitor your containers here. You can see my container is not using too much memory. It doesn't have any load. I just created this container to show you this information. Of course, you can stop the container here. You can even delete it. But let's take a look at something before getting rid of this container. If you go to the containers part section, excuse me, you can see all the events that has happened to this container. When it was created, when it was started, when it was stopped, and everything else. You can see the metadata or properties. Exactly the same information I show you on CLI. Nothing fancy. Here's the logs. Remember we saw that there had this essay trying to connect. That's one application I have. So it's here. And you can even connect to the actual container. I mean, inside the container, and I'm right now inside the container, if you can see. I'm MS SQL, and let's grab the host name. The host name is going to be this large number, which is an identified that Azure puts on as a container name. So pretty standard, and let's play around. Imagine I don't need this container anymore. For some reason, I am done with my work today, so I can just stop it from here. And it's done. Imagine doing that with VM. It's not going to take that. It's not going to be that fast. I can restart my container here again. I can say starting a container on Azure sometimes takes a little longer. Sometimes it's shorter. Probably is because these containers are living on VMs or somewhere else in Azure data center. So based on my experience, that takes a little time. But deleting the container, stopping a container doesn't take that longer. See, it's still starting the container, and we should be able to see on the activity logs that I stopped the container. Let's take a look for a moment. Probably it's my internet. Yep. See that I stopped the container and now it's starting. Probably it's up. It's not up. Yep, it's up and running now. So it was just a minute probably. Let's do something crazy. Let's delete this container. I don't need it anymore. So why not deleting it? So I'm deleting my container and it's done. So it's gone. Probably it's still here around because this is my dashboard. Let me refresh my dashboard. There you go. It's gone. So it's really easy. Anyway, I include some examples here how to do it with ACI, the Azure CLI if you want. But as you can see, you can create your container just in a couple of clicks and get rid of the container in a couple of clicks as well. And this example is to give you a little bit of history about this demo. I have this friend of me that he asked me, hey Carlos, we are a really small shop. We are just like 4 developers and we need to have a SQL Server VM on the cloud or Azure SQL DB, but we don't want to spend too much money and we just need to use this SQL instance for a couple hours. and that's done. That's exactly what I taught you during one of the slides. So they were able to create these containers, get the job done, and then delete the containers. Was really practical for them and really easy, and the cost benefit is huge. Okay, so let me show you a different example now. I will move to something different. In this example, I'm going to show you how to make a deployment of objects into a SQL Server container, just to make sure and clear any question that containers are the same. I mean, SQL Server is the same. Just running on a container, what happens to be the SQL Server we love and know. Okay, so this container is up and running already. Is called the development 02. I'm just querying the status, and it's running. Cool. So I'm going to connect inside the container for a moment. So I'm executing beam bash from my computer to the container running in the cloud. So I'm in, and I created a temporary bash profile just for visualization purposes. And now let me show you something really cool here. This container is a little bit special because I integrated this container with Azure File Share, which is part of an Azure storage account. What those mean? Well, it means that I was able to create a container that has a volume that is mapped into an Azure file share. That means that I can copy files from my computer to this file shared in the cloud, and those files can be used by my container. So let's do it. Let's go to Azure File Explorer. For those that are not familiar with this tool, it's really simple. Azure Storage Explorer, excuse me, provides you like a graphical user interface where you can interact with your storage account. So in my case, I have my file share here, and I have a couple of folders that are mapping to my container. I'm going to upload something to SQL scripts. So let's upload a couple files. Let's upload a file. Going to grab a file from my computer, and yep, this one. I want to have this script. For some reason, I want to have the script to create a database on my container. Right, it's done. Let's go back here. I am on my container now running on Azure. So I'm going to list everything inside the SQL scripts folder. You can see that I have the file that I just did it a minute ago. So I have my file here. Cool. So what about if we run a deployment? If we execute SQL command, and let's have SQL command to execute this script. By the way, the script is going to create a database. As I said, it's going to create a human resources database. It's going to create some tables, insert some data. So pretty much the standard things you are used to do all the time. Let me go back. Or there you go. Okay. So let's execute this. All right, it's done. It created the human resources database, and 6 row was affected for a couple of tables. Let's run a query and check what are existing databases on this container. You can see my human resources is there. If I go to Azure Data Studio, because I want to have this look and feel about what's going on my container. Let me refresh here, list the databases. I don't know what's going on. Yeah. Let me disconnect for a moment. Looks like Azure Data Studio is not cooperating with me. Yep. Let me close it. For some reason, I'm having this trouble with Azure Data Studio sometimes. I need to reopen it. Sorry about that. It won't take longer. All right. We still have time. All right. really don't know what happened. It is suffer. Okay, there you go. So let's connect to O2. Wow. Looks like it's only I lost the connectivity to Azure. Can you guys hear me okay? Is my connection working fine? Hello? Well, probably they are there. Okay, I can connect now. And there you go. Not sure what happened, but a little glitch. Oh, I know what happened. This Devo1 container that I had before was trying to reconnect, and that was stopping Azure Data Studio to connect me to your sources. Well, but at the end of the day, we are here. So I have the human resources here. I have my tables, and I have data, of course. Let's explore the data. Well, if you want, we can explore data, but the data is here, trust me. So I created a database from a container, copying a file from my computer. So that's pretty cool. You can do a lot of stuff here. Okay, let's move on to something more interesting. Last example I have about ACI. It's more interesting. Okay, so here you go. ACI provides me a platform where I can run containers. Okay, I can run a group of containers if I want. What that means? That means that I can deploy multiple containers to be part of one single group. So like a grouping or a resource group. In case on this case of SQL Server, I was able to create an AG using this read scale functionality of SQL Server 2017. I can show you the deployment. That kind of deployment requires to be a YAML file. In this case, my container group is called read scale. Pretty much standard information about the name of my container, the image of my container. Here's my resources I want to use. I want to use 2 gigabytes of memory, two CPUs, my port, the environment variables, and anything else. But you can see that I am repeating this one time, and then I have almost exactly the same information again, because I am creating the container 1 and container 2 to be part of my AG. So this is going to be pretty much my first replica, my second replica. Of course, they are using a different port here. And that's it. Then you create a DNS level for your group. You define the ports you're going to use. Of course, are the same I have here. It's map. So it's done. Let me show you how container group looks on the portal. Just let me find my Explorer, and it's here. The interface is a little bit different on the containers here because I have 2. You can see I have my master 1 and master 2 running. And I can go ahead and check the properties of every single container here. I can take a look at the logs. It's pretty much the same I did before. And again, it's a SQL server running in the cloud. In this case, it's a SQL server running on a container and also being part of an availability group. How cool is that? All right. So let me go back to Visual Studio Code. I'm flipping around a lot of. Sorry about that. Just lost my. Let me do something really quick here. Let me address this. I'm going to go here. I don't need this anymore, so let's close it. Go Azure Data Studio here, so that's better. Right. So if I want to explore the information I show you on the portal, I can do it from here. But I will skip that part to move forward to do something different now. Okay. Let me go back to my presentation. Okay, so a quick recap of what I did. I show you the CLI and portal experience. Azure Container Instances using an Azure file share. You can even copy information from your computer into the cloud and, of course, into a container. You can use something like Azure 5 Blur to do it using a graphical user interface if you want. You can use the portal if you want. We have this option of multi-container deployments, which I know probably could be a little bit scary at the beginning, but it's YAML. So there is many tools that can help you to make sure your YAML, it's the YAML file is formatted correctly and you're following the exact keys and everything else. Okay, let's move to Azure Kubernetes services. and and this is really a certain piece of Microsoft. If what Microsoft is doing from the container orchestration standpoint in Azure, Kubernetes was created on making things easier and also to run multiple containers in a single platform. It's not just designed for SQL Server, just to be clear. As I said, it is a platform where you can run many containers. So obviously, these containers needs to talk each other in order to do what they have to do. They also need to see each other. They need to do some load balancing. They need to consume the storage capacity. They also need to do deployments. They have to have health check. So there's a lot of complexity involved that you will probably don't want to be fully responsible. Of course, there's a lot of moving parts. There are VMs on the background. There is even an internal database called etcd that you have to maintain sometimes. You have to back up, but there is a solution for everything, always, right? And that's what Microsoft has done with AKS, excuse me. It delivers a fully managed experience for Kubernetes to make your journey with this technology easier. You can focus on submitting your manifest into Kubernetes, and Kubernetes is going to do whatever you ask to orchestrate, while maintaining the desired state on getting the job done. So why AKS? So there are so many reasons you can choose this Azure service. It comes with a really nice management features around the Azure portal and Azure CLI, of course, where it's just a matter to change the configuration to scale up your cluster or trigger an update without really having to worry about the tedious infrastructure management stuff. Fully integrated with ACR and ACR and excuse me, ACR and ACI. And I didn't go into much detail about it, but you can even create, as I said, RBAC roles on ACR. You can integrate ACR with AKS. You can make deployments of images that are hosted on your Azure Container Registry. Trust me, it's lots of stuff. And it integrates with ACR really cool because you can scale up your cluster using virtual nodes, and that could be on demand. You can even auto scale in terms of seconds, and that will be when traffic comes to spikes. But what are those virtual nodes? Kubernetes has something called a virtual node or kubelet, where it takes advantage of ACI and it creates containers as nodes, and so you can scale up your Kubernetes cluster using these virtual nodes, and you can just do it on demand or you can just do it on auto scale. There's many options there. There is lots of information. So again, fully managed with automated patches, automated upgrades, integrated monitoring, fast end-to-end development experience with VS Code, Azure DevOps, Jenkins, or anything else. And finally, let me tell you this, the AKS team of Microsoft is doing a really great job keeping up with the current versions of Kubernetes. I think they are Microsoft is the best cloud provider for AKS and for Kubernetes in my experience. They are using the closest version supported on Kubernetes on-prem or anywhere. So they are really doing a really good job there. Okay, let's have a demo with AKS. Let me find Visual Studio Code. What? All right. All right, so we have 3 minutes late, 2 minutes left, excuse me. So demo number 4. Okay. So if you are interested to deploy AKS cluster from Azure CLI, in my GitHub repository, of this presentation, you will find example of how to deploy a Kubernetes cluster. It is using variables, so you can change things around, but pretty much everything is here. Also, if you are interested to deploy SQL Server on Kubernetes, everything is here as well. I'm including the deployments, the persistent volume claims, the services, and everything else I'm using to create these couple of instances on my AKS. I have two instances. I have one, it's called Plex, which is simple. It only has one persistent volume claim, and I have TARS, which is a little bit different. TARS is always different. If you're familiar with Nolan movies, you will figure out that Plex and TARS are robots from that movie. TARS has a different configuration. I happen to create a couple of things that I will show you later if you want, but we can address it from here. TARS has different volumes. I created a volume dedicated for my user databases, one for the logs, and one for the system databases. You can do all the stuff you're used to do with SQL Server on running on containers. It's just a matter to know how to do it. So you have examples here how to do it. Let's explore something really cool. Remember, I mentioned that we're looking for durability, network connectivity, and high availability. Kubernetes provides us that out of the box. So let me show you that. Let's run my environment. I want to make sure I'm pointing to the right Kubernetes cluster, and my cluster, by the way, is called Endurance, and I have namespaces. I have a different namespace for Plex and a different namespace for TARS. That is because I want to separate things. I don't want to make my deployments in a single namespace or the default namespace. Namespaces works exactly the same are used to on .NET or any development language. Let me show you my nodes. This is the nodes on my cluster, a couple of nodes, nothing fancy. Here's my pods in all my namespaces. You'll see I have a lot. I have Plex here, TARS. The pod is where the SQL Server container is running. But let's take a look at Plex for a moment. And here's my pod for Plex. No, excuse me. This is my persistent volume claim. And a persistent volume claim is a volume that is mapped into a disk on Azure. So here's the name of my volume. I can figure out which disk was provisioned to this pod, and this disk is going to be presented to both of my nodes. So whenever something happens to one of the nodes, SQL Server is going to move Kubernetes is going to move the pod from one node to the other, and my data will be the same. And this is exactly what I'm going to do now. I'm going to skip this part. I'm going to go back in case we have time at the end, but it was just to show you my volume and the disk on Kubernetes. All right, so let's do this. I'm going to do something really crazy here. I am going to grab my service first. The service is going to be the IP address I'm going to use to connect to SQL Server, and I can connect from here, obviously. Here's the name of my instance. Here's my version. So what I'm going to do next is going to create a database. Let's create a database, the same database I created before, human resources, a couple of tables with some data, nothing fancy. Let's take a look. I have my database here. Yep, it's there. So what I'm going to do next, as I said, it's a little bit crazy. I have a pod running on this Kubernetes cluster, which is hosting my SQL Server container. I'm going to delete that pod. What I'm going to prove with this little failure here is that SQL Server is persistent on Kubernetes. The data will be the same. My database will be there. My tables will be there, and Kubernetes is going to kill it's going to create a new pod. It's not trying to resurrect the pod I killed. It's going to create a new one. It's going to move the SQL Server container, and it's going to present the volume again, and my data will be there. Let's do it. All right, so it's going on. This is the name of my previous pod. It is a complex name, but you can see that ends with, oh, it's done. But let me go back here really quick. So the name ends with CVM6B. So then I killed the pod, and I had a little bit of monitoring there to make sure a new pod is created. As you can see, a new pod was created. It's running, and here's the log of what happened after the pod was started. SQL Server was up and running, and it was getting ready, and that's it. All these outage, quote unquote outage, if you will, took less than 4 seconds. Well, that means that the database I created before should be there. The data should be there. So let's make sure that happened. Remember, I was connected here before. As you can see, my connection is the same. Azure Data Studio didn't notice what happened. My human resources database is there. So what about if I run a query really quick? That's the last part of this demo. Where'd the query go? There you go. Let's run a query to make sure my data is there. All right. So this is going to grab the version of SQL Server, is going to grab the list of databases, is going to list the tables, and finally it's going to list the data on those tables. Let's do it. Done. So again, SQL Server is the same, running on containers, no matter if it's running on Kubernetes, it's running on the cloud, it is the same SQL Server you are used to work. And we have durability, we have network connectivity, and everything else. So recap of this demo: compute and storage is separate. I just demonstrate that my volume was persistent no matter what happened to my pod. Kubernetes uses declarative management. I show you a little bit about the YAML files I used to deploy this. High availability out of the box. Of course, I killed my pod and it was recreated a different pod. Manage control pane. Everything could be managed from Azure portal. And I don't have the time to show you that, but I can do it at the end. Let's see. So a quick review. Azure Container Registry. This service that allows me to build, test, and push images into Azure. Then I have Azure Container Instances, where I can run, integrate, and test my containers on the cloud. And finally, I have Azure Kubernetes Services, where I can deploy, I can orchestrate, and scale my containerized applications, in this case SQL Server, on Azure. Okay, so I think we're done. I don't know if we still have questions, if we still have time for questions. Can you guys hear me okay there?